Ladies and gentlemen, I am honored to have the opportunity to participate in this meeting. I shall take about 10 minutes of your time. The title of my academic presentation is Research on Debounce Method of Electronic Imaging Equipment Based on Feature Point Matching. First of all, I want to introduce myself. I am from Chongqing Telecommunication Polytechnic College in Chongqing, China. I have divided my presentation into 4 main parts. Is there such a scene in your mind when you look at this picture? When you take pictures of the beautiful scenery on the high-speed rail, the result is usually disappointing that blurred pictures. It's so uncomfortable. Electronic imaging is not just for taking pictures. The demand for images in various fields is increasing, and the equipment becomes more and more diversified, which can adapt to any scene. But in a dynamic environment, it is easier to cause the electronic imaging equipment to shake and cause the image to blur. For this, to shake it has become an urgent problem in this field. Aiming at the problem of image generation blur in existing electronic imaging equipment to shake methods. There are some of traditional methods, such as a digital method, based on a self-reference source, which does not require 2 similar sources, to be measured under the premise of satisfying high measurement accuracy. Which greatly reduces the complexity of the measurement system. Then, the structure of the measurement system is optimized. The mechanism of the artifact peak in the optical fiber delay line system is explained, and the second-order difference frequency cone model is proposed to realize the de jitter processing. Experimental results show that this method can effectively improve the accuracy of de shake, but ignores the time-consuming situation. The other method is use the de shake blur algorithm to restore the original image information of the blurred image, and then perform point-based restoration based on the motion recovery structure. The dense three-dimensional reconstruction of the cloud, and finally the Poisson surface reconstruction of the densely reconstructed point cloud to obtain the surface density and realize the de jitter processing. The experimental results show that the de jitter effect of this method is obvious, but it takes a long time. For the above questions, I propose as a research on the de shake method of electronic imaging equipment based on feature point matching, can not only solve the problem of blurred image, but also shorten the time of de dithering and improve the efficiency of de dithering method. Next, let us see the specific implement method. The method of electronic imaging equipment de shake based on feature point matching. Firstly, perform feature point matching on the motion path of the electronic imaging device, obtain the motion characteristics of the device using constraint conditions, and implement the motion path feature matching processing of the electronic imaging device in combination with the matching feature window. Secondly, use the two-dimensional spatial relationship of the image to perform rotation, translation, and zoom processing on the resulting image.
Based on the electronic imaging equipment operating model, the 6-parameter radiation method is used for motion estimation, and the motion curve characteristics are determined and modified according to the base function synthesis curve. The optimized processing of the estimated value then obtains the shake result of the electronic imaging device.
In the study, CMD300 of CMOS Company is selected as the photoelectric platform sensor, and the effectiveness of this method is verified by comparing with the high-precision time jitter measurement method based on self-reference source. The stability of the electronic equipment determines the quality of the image. The more stable the electronic imaging device, and the better the shake effect. There are two evaluation indicators for the stability of electronic imaging equipment, PSNR and MSE. PSNR, peak signal-to-noise ratio method. PSNR.IT reflex is the peak signal-to-noise ratio of the reference image frame, and the current image frame. It is an index for evaluating the standard degree of stabilization algorithm. The larger the PSNR value, the more stable the electronic imaging device, and the better the shake effect. If the motion vector of the two frames is 0, the PSNR value should be infinite. MSE, the mean square error. MSE is the sum of squared differences of each pixel between two frames of images. It reflects the speed of the image sequence change and the magnitude of the change. The smaller the MSE, the more stable the electronic imaging device, and the better the shake effect. It can be seen from figure of PSNR comparative analysis.
When the traditional method is used, the PSNR value is about 56.84 decibels and the fluctuation is large. When the method in this paper is used for jitter processing, the PSNR value is about 72.64 decibels. The fluctuation is small, and it is 15.8 higher than the traditional method. dB.
It can be seen from figure of comparative analysis of mean square error. MSE.
When the traditional method is used, the MSE value is about 30.64 and the fluctuation is large. When the method in this paper is used for jitter processing, the MSE value is about 12.54. The fluctuation is small, and it is 18.1 lower than the traditional method.
The experimental results show that the dithering effect of this method is better, and it can be effectively applied to the image blur problem caused by electronic imaging equipment in dynamic environment. It is of great significance to electronic imaging technology. The article proposes an electronic imaging device shake method based on feature point matching. The results are obtained through experimental analysis. When the method in this paper is used for the jitter processing of electronic imaging equipment, the PSNR value is about 72.64 dB and the MSE value is about 12.54, which are better than traditional methods. It is improving the shake effect of the electronic imaging device. This method solves the problem of image blurring caused by the electronic imaging device in a dynamic environment to a certain extent.
However, due to the limitation of research conditions, the time-consuming situation of Deshake electronic imaging equipment needs to be further considered in future research, so as to enhance the efficiency of the Deshake method of electronic imaging equipment and improve the practical application effect of electronic imaging equipment.
That's all, thanks.